everybody and welcome back. Today our topic is going to be recording the ECG leads. So we're going to talk about the leads of the ECG. Recording the electrical activity of the heart can be measured with voltmeters connected through electrodes at the surface of the body. It can be negative or positive or null, which is isoelectric. Electrocardiograph lead systems. The ECG lead systems. Recording electrodes are configured to form various types of leads. A lead records the fluctuation in extracellular voltage generated between its electrodes. The standard clinical ECG includes recordings from 12 leads, 6 in the frontal plane and 6 in the transverse plane. The 6 frontal plane have 3 bipolar leads or standard limb leads and 3 modified or augmented unipolar limb leads. So 3 bipolar and 3 unipolar. These are the 6 frontal leads. For the transverse plane, it has 6 unipolar precordial leads. A bipolar lead. We're going to explain the bipolar lead first. It consists of 2 electrodes placed at 2 different sites. It registers the difference in potential between the 2 sites. The actual potential at either electrode is not known. One electrode is designated as the positive input, the other as negative. A unipolar lead. A unipolar lead measures the absolute potential at one site. It requires a reference site. The potential is sensed by a single electrode, which is the recording of the active electrode considered positive in relation to the reference potential. Now we're going to talk about the bipolar standard leads in details. There are the first 3 leads, so lead 1, lead 2 and lead 3. Lead 1 is negative connection to the right arm, positive connection to the left arm. It defines an axis in the frontal plane at 0 degrees. For lead 2, it's negative in the right arm and positive to the left leg. And it defines an axis in the frontal plane at 60 degrees. For lead 3, it's negative to the left arm and positive to the left leg. And it defines an axis in the frontal plane at 120 degrees. The output, the potential difference between the 2 limbs, are the output. The Ian-the-Venz triangle. The Ian-the-Venz triangle is delimited by the axis of the 3 standard limb leads. If the Ian-the-Venz law is if the electrical potentials of any 2 of the 3 bipolar limb electrocardiographic leads are unknown at any given instant, the third one can be determined mathematically by summing the first 2. The positive and the negative signs of the different leads must be observed when making this summation. So 1 plus 3 is equal to 2. So lead 1 and lead 3 can be added together to give us lead 2. For augmented or unipolar limb leads. The 3 augmented unipolar limb leads compare one limb electrode to the average of the other 2, which is called the Goldenberger method. 2 of the limb leads are connected through electrical resistances to the negative terminal of the electrocardiograph, and the third limb is connected to the positive terminal. Now we're going to explain them. They are the AVR, AVL and AVF. AVR is augmented voltage right, for the right hand. Its positive connection to the right arm. The axis defined in the frontal plane is at negative 150 degrees. For AVL, it's augmented voltage for the left arm. its positive connection to the left arm, and the axis is defined in the frontal plane in negative 30 degrees. For the AVF, its augmented voltage for the foot and its positive connection to the left leg, and the axis defined in the frontal plane is positive 90 degrees. So this was everything for today. Thank you very much and hope to see you soon again in the next video.